A point source of light O of a single color is seen through a rectangular slab, PQRS. The path of the two rays in and outside of the slab are shown in the figure here. You can see in the figure here. There is a point source O here, and it has two rays coming from there, one going a bit slant, and you have to draw them. What do we draw? A perpendicular, a normal over here. You can see it has bent towards a normal because this is a rarer, denser. And you have to draw another normal here, okay, from the other part. Here, put it here. You see it has bent away from it because it's denser and rarer medium. Okay, so they have given this figure here. There is a point source at O. So two rays are coming. One is coming in this direction. It bends towards the normal. Again, it will bend away from the normal. Another is going, okay, incident on the prism, sorry, not the prism, on the rectangular slab at 90 degree. What is it? At 90 degree. So if this is 90 degree, it will not get deviated. It will go straight and come out straight. Okay, simple. Fine. In the diagram, label the position of I of the source O where it will appear when seen through a surface RS. So when you are seeing it from surface RS, means outside this surface, where will it be seen? So this is the emergent ray, right? So if somebody is over here, okay, if somebody is over here, so how will you see that? So for him, the ray of light will look straight. The body will look just in front of in a straight line. So what do we have to do is we have to draw a straight line here from this point. So, okay. It doesn't go that. So if you see this straight line, does it look like that? Slightly more, I believe. Yes. No, this is more. No, this is okay. So if you produce this line backward, right? Same line. So wherever it is there, it will be seen. The object will be seen where? This object which is there will be seen where? At this place. Okay. Got it? Let me make it red so that it can be visible, right? So the answer is in the diagram, label the position of I. This is I in it. So I can say this is I. Now, where it will appear will seen through the surface RS, means outside the surface RS. Does the source O appear to be nearer or farther with respect to the surface PQ? So no, actual is this one, but it is seen over here, so it is nearer the surface PQ. So answer for this one is what? Nearer to surface PQ. You can see this image is seen here, not there. This is away, this is nearer. How does the shift depends on the thickness of PS and QR? Okay, thickness of PS and QR means if this is this much of thick, we see the object here. Let's see if it is not that thick, if it is less thick. If it is less thick, I can make a, okay, say like this. It is with this thick here. Not that much, but less. Let it be like, say, this thick now. Then if it is this thick, where will the object be seen? So how will you see that? The ray of light will come from here parallel, okay? So ray of light will come from here as a parallel, and that will be here. Come on. No, that doesn't happen. Just one second. The ray of light will happen like this, okay? It will come parallel from this point. Why? Because this point here, right? So it will be something like this. Because the emergent rays are always parallel, okay? So somewhat here. Okay. It looks parallel now. Okay. So from this particular normal, I have to draw a line parallel to it. So wherever they intersect, there will the image be formed. So this image is formed where? At this place. Got the point here? Fine. This image will be seen at this place here. Okay, here. So now, how does the shift depends upon the thickness of the PS and QR? Okay, when we change the thickness, we reduce the thickness, the depth, right? The apparent depth decreases, or we can say the shift decreases. Actual shift was from here to here now, earlier. Now the shift after we have reduced the thickness, it is this much. Okay, so the shift decreases in it. Justify the answer with the help of appropriate diagram. I already have done that for you. This is the figure that we have to draw. So we have to draw a line parallel to this one from this particular thickness. And wherever it meets this particular ray, which is perpendicular one, there is a image form, and it is formed over here. Clear? So this is the apparent shift, and that is, it's showing that the shift is less as compared to the other one. And we have done this earlier in the previous video. If the thickness of the medium decreases, then the shift decreases in it. Is that okay? And how you can see in the figure. For same rectangular glass slab, which color from the visible spectra, violet or red, will produce maximum shift? Remember that shift depends upon the refractive index of a particular color, and it depends upon the wavelength of the speed of the light. Is that okay? We know that red has got higher speed and violet has got the lower speed. It has got bigger wavelength and this has got smaller wavelength. Smaller wavelength means it has less speed, right? Less speed of light, and here it has more speed of light. If it has less speed of light, it will bend more. It will bend more. It has more speed of light, it will bend less. Is that okay? Bend less. So the one which bend less will show less shift. Is it clear? Fine. And which bend more will show more shift. So this will give you more shift. More bend more means more refractive index, right? We can say more refractive index, and it has got less refractive index. If it has more refractive index, or we can say this is Ri, refractive index, right? Then more bending, and it will more refractive index means more shift. Okay, we have done that, and this will have less shift. So which one will have more shift? Violet will have more shift and red will have less shift. They're asking maximum shift will be in violet. Is it clear? So this is how we have to solve all the questions that we had here, right? Fine. It was is basically is a mixture of all the properties of, like, say, light, refraction of light, that is related to the shift, and we had done that earlier. We have to apply this in this question, including the diagram.